Okay. Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. So we have student from EMM3306 Fluid Mechanics 2 and I am Rizky Jayamunandar. My metric number is 199634.
My name is Ahmad Arif bin Cisman and my metric number is 196813.
And my name is Aiman Fitri bin Shahrom. My metric number is 198590.
Okay, so today we would like to present about the motorboat prototype. So the introduction of the motorboat prototype is that motorboat is the transportation vehicle that can be used to transport people or material from one place to another. Most motorboats are built with good quality material and high technology engine, which can give assurance in safety and versatility. And in the late 19th century, the boat was powered by a petrol engine. And then the first people who tested the motorboat using a petrol engine is Gottlieb Daimler and Wilhelm Maybach in 1886 with their new engine, which is the longest clock engine. And the structure for this motorboat comes with variety type, especially from the hull construction. There is different in height for the hull. There are three main materials used for this motorboat, such as wood, reinforced fiber, and metal. From the design and structure that has been used for the motorboat prototype is proportional and compromising for achieving the aerodynamic layout, and also the lowest drag force aerodynamic that occur in the motorboat itself. By having a good design and structure, it can lead to good distribute energy to the motorboat. When it accelerates forward, this is where the motorboat can be assured to use for different purpose. And what is the problem statement we found when doing this motorboat prototype is that the fast moving air and water current, or called the hull resistance, will generate and cause the force drag aerodynamic on the stream of motorboat that can cause the lift aerodynamic overall while can decrease the drag aerodynamic. The height of the boat hull itself is really important to make sure that it can lower the drag force coefficient. That's why in ANSYS CFD analysis application, different height of hull structure are applied to find and achieve the lowest drag force coefficient that occurs in different type of hull structure. And my friend will continue talking about the modeling.
Okay, thank you, Rizky. Okay, for my part, I will explain about the modeling. What is the modeling of motorboat prototype? First of all, for the modeling design, we create that we using CATIA software because the CATIA is a world engineering and design leading software for product 3D CAD designs. And this software also is used to design, stimulate, analyze, and manufacture a product in a variety of industry, including aerospace, automotive, consumer good, and industrial machinery. Next slide. Okay, the first design that we created is this design, this prototype of speedboat, a prototype of motorboat that are actual, but it is it's just a prototype from the actual boat. And as you can see, there are three parameter that we show to you. The first one is length of the body is 1.2 meter and the height 0.045 meter, width is 0.09 meter. This is our first design. Okay, next slide. Okay, for the second design, as you can see, we increase the height, or we it's not increase the height to become more high, so that we are using different types of design. You can watch you can look the length, the height, and the width. The length is 0.2, also the same. We actually only change the height of the ship. It's about 0.065 meter. Design 3, please. Okay, for the last design is this design we decrease by half of the from the both design, which is the first design and the second design. The third design is the height of the third design is 0.04 meter. Okay, actually, when we are using the Katya as a designer, and when we change the file into the SolidWorks to analyze, it become different prototype. I don't know how we don't know how to change it, and uh, but uh, but you can see, but you can look at the file I will give it to you, and if approve, and you can see, because after this I will explain mesh and CFD. It's not by based on this design, but based on the SolidWorks design that I can't change it because it's changed automatic. Okay, for next one is this one mesh. Okay, the first design, the second design, third design are used. It's not that are shown at the modeling, but I will give the file and it will. I will not show it here because the file is not hard to capture it, and you can see it by your own. Sorry, Prof, that we did it can do it right, but we try to do the best. Okay. From the design that we are created, the mesh is about control, including sizing, function, inflation, smoothing, differing, parameter input, and assembly machine input based on the part that is selected. This function was made to smooth the fluent projected on the body. Okay. Okay. I think that that's not much I can tell this table, because this table are from the mesh data that we get from the SolidWorks analyst. Okay, next slide, please. Okay, this one is a fixed parameter that we use to do at the simulation. The first one is the velocity of water is 100. This is because uh, the the boat are moving forward, and but the what we call the velocity
Flow
of the
of
water
water.
uh, is
Inside the tank.
opposite of the boat. Why is it? And the pressure we maintain 1 mtm. The pressure also maintained 293 Kelvin, and the density also we maintain 997 kilogram per meter cube. Next slide, please. Okay, the last one is for me is CFD. CFD is able to analyze complex problem involving fluid to fluid, fluid solid, or fluid gas interaction. Next slide, please. Okay, this is the first step that we can use to do the CFD. We have to select. No, no. Okay, we have to select wizard. Okay, you can look at the picture. There are wizard. Okay, you can choose the wizard. After that, it will become this one, the project name, and you can put the project name as long as you want, what the name that you want. Okay, next slide, please. This one, when you create finish, and next before this, it has internal and external. You have to choose external first, then you go to this one, proceed this one, and you choose fluent, and you got water for this motorboat, a motorboat prototype. You use water because it boat in water, right? For this, we choose the water to certify the CFD. After that, the wizard will complete. Next slide, please. Okay, we come here. After that, we choose compositional domain, and it will create the, you see the square, and it can use for to create dimension, to create the dimension for analyze. You can up, you can 3D design. Yeah. Next design. Okay, the next one is to select goals and choose all goals that satisfy. I'm using insert global goals as a reference to XYZ for drag force, leaf force. That's two only. So only and insert equation. That's all. Okay. Okay.
Okay, thank
That's all
you.
from me. Thank you.
Thank you Ahmad Arif, BNT Seman. So starting from the results slide until the conclusion, I am Fitri and I will continue the presentation. So as we all know, after we finish the designing process and using the simulation, it times to check the result of the simulation. So as we can see, there are stated design 1, design 2 and design 3 and the list of data that we need to input put in the result in the report. So the first one is lift force, the second one is drag force and lift coefficient, drag coefficient and the projected area. So when we done the simulation, we can get from the software as stated in the slide, where for the design one, the lift force is 6206.9. The drag force is negative 4735.1 because it come to the opposite direction. So the lift coefficient is 0.397. Drag coefficient also comes from the opposite direction. Then it become negative 0.303 and the projected area is 0.0016. For the design, the second design, the lift force is the greatest where it is 7316.3 and the drag force is negative 8574.1. The lift coefficient is 0.25. The drag coefficient is negative 0.295 and the projected area is 0.00584. So for the last design, the third design, you can see that the lift force is 5507.33. The drag force is negative 14,554.4. The lift coefficient is 0.473. The drag coefficient is negative 0.39 and the projected area is 0.007. So that are the results and data that we can get from the simulation software. So next slide. So for the discussion of this experiment, we can see that the lift force of the second design is the highest. Sorry, compared to the first design and the third design. This happened because the lift is greater than the object weight. The lift force is greater and than the object weight. So this can make that the second boat will float on the water. So as we can see from the buoyant force law, if the buoyant force is less than the object weight, so the object will sink. If the buoyant force is equal to the object weight, the object will remain suspended at that depth. And if the buoyant force is more than the object weight, so the object will float as the second design. So the second design has the taller height body, which is 0.65. What this is why the second design has bigger lift force, which is 7316.3 Newton. So taking the value of drag force obtained from this table 6.0, where the result table from the previous slide, design 3 has the highest drag force, which is negative 1455.4 Newton. The value is negative due to the force that across the opposite direction from the board that I said before this. So next slide. So when the drag force occurred, the force produced from the boat was lowered and eventually reduced the speed of the motion when accelerated forward. So as we know, when the motorboat move and it has to opposite the water or drag force. So if the drag force is higher, so the movement of the boat will be slower. So based on the both three design that have been made and analyzed, there are their own advantage and disadvantage according to the hull design. So this is depending on the height. So the motorboat is a vehicle that need a good amount of speed to accelerate and the lift amount, so it will not sink on the water. So based on the result of the CFD analysis, we can we can see that the first design has the most efficient design that has been analyzed because it has the we get back to the result, Rizky, because we see the design first, it has the lowest drag force, which means the boat can move faster than design 2 and design 3. So get back to the slide. So the first okay by the design first design make the boat can move freely and faster and it float because of the good buoyancy or lift force. So next slide. So the last one from me is the conclusion. So the first motorboat prototype approved has the best design compared to the second and third design. This is because the first design has a good amount of lift force. So actually it can, we want to say that it can float on the water but not sink. So I think that all the boat has a lift force that make they float, but the special for the first design because it has the lowest value of drag force, which lead to the lower aerodynamic and water resistance when it accelerate forward, and it makes the move is efficiently free and fast on the water, better than the second and third design. So I think that's all from us. So thank you for lending us your ear, and we hope that you all can understand our presentation. So thank you very much.
Thank you.
Assalamualaikum.
Thank you.